Okay. In this video, we'll discuss about the photochemistry of diazo compounds and photochemistry of cycloadditions of with molecular oxygen. So firstly, we'll take the diazo compounds. Diazo compound is nothing but a CH2N2. So this CH2N2 diazomethane on irradiation with the light, it will give you the carbene, and the carbene are of two kinds. One is the singlet. Here the electrons are opposite spin, and here the electrons are parallel one, same spin. That's called the triplet. So then carbene undergo following the reactions. What is addition reactions and the insertion reaction and the rearrangement reactions. Addition reactions involve the triplet carbene additions are and the addition of carbene of triplet carbene is a non-stereospecific one, and the addition of carbene, a singlet one, is a stereospecific one. So with this, I will go to the next slide. In the next slide, I am taking few examples of carbene addition. So here is I'm taking one carbene addition. So carbene addition means CH2 addition to the double bond. So cis-butene I am taking. The carbene one is in situ generated, and formed one is the stereospecific one. Because why it is stereospecific? Because the retention of configuration of the substrate in the product. So similarly, taking trans one and the triplet carbene. In this triplet carbene, as you know that electron spin is required to form a bond. That's the reason a racemic mixture is obtained, and it is a non-stereospecific one. We'll go to the another slide. In that slide, a ground state olefin react with the diazomethane on irradiation. It will give you the, and the singlet one means diazomethane singlet one will be the stereospecific one. That means retention of configuration. Diazomethane on irradiation, it will give you the, this opposite spin electron one is the singlet one. So here I am showing the mechanism. The cis-butene react with the singlet one. Since there are opposite electron spin, there is a bond formation. Similarly, here also, the obtained one is the cyclopropane ring. And obtained that a retention of configuration with respect to the alkene. So then I will go to the another example. Again, cis-butene and on irradiation in presence of light. This one will give you the mixture of compounds. Why mixture of compound? Because of the triplet formation. So triplet form easily one bond formation, and for the other bond, rotation of methyl group is required. That's the reason it is observed that racemic mixture. Similarly, if the alkene is treated with in presence of diazomethane, more particularly diazomethane ester, so it will give you the bicyclocyclopropyl ester is the product. I will go to the next slide. On the next slide, I am taking a insertion, more particularly a alpha diazo ketones. Alpha diazo ketones are irradiation. N2 will be going, and there is a carbene formation. This carbene undergoes CH insertion. Thereby, it forms a bicyclic ketone or the product. Similarly, if the N2 is attached to the alpha diazo ketones on irradiation with light in presence of methanol, this leads to a contraction, okay, contraction of the ring size. So 6-membered ketone is converted into 5-membered cyclohexyl ester is the product. Similarly, here I am taking one example. The example is tetralone, alpha diazotetralone. This on irradiation in presence of methanol gives you a cyclobutano-benzene ester is the product. Norbornene adamantane kind of one on alpha diazoketone on irradiation with methanol gives you a 5-membered bicyclic moiety. Conversion of 6-membered one into a 5-membered one. I will take one more example. So in this one, I'm taking alpha cis butene and also trans butene. So cis butene singlet diazomethane reaction, it will give you the retention of configuration, and these are stereospecific one. Similarly, trans butene on reaction with diazomethane in presence of sunlight with the singlet formation, singlet addition, singlet carbene addition to the trans one is also a stereospecific one. I will go to the next slide. In the next slide, I'm taking cis butene and trans butene addition of triplet. So here you can observe that triplet one requires the spin rotation, means methyl group should rotate to form a bond. That's the reason it is observed that a racemic mixture is obtained, and it is a non-stereospecific one. Similarly, for the trans butene. I will go to the next slide. In the next slide, the molecular oxygen addition, cycloaddition to the diene. So the obtained one is the tetracyclic moiety. Similarly, a diene react with molecular oxygen, forming a 6-membered ring with oxygen as the heteroatom. And here is the mechanism how the molecular oxygen react with the butadiene. So a biradical are the intermediate, 1,4 biradical are the intermediate. Later on, bond form, bi-bond cleavage and then bond formation. This is again a mechanism how a 6-membered ring with 2 oxygen and 1 and 2 position is cycloproduct is obtained. And these are again natural compounds, naturally occurring terpenoids, on treatment with the triplet sensitizer and oxygen in presence of sunlight, it will give you the hydroperoxide. Hydroperoxide will be isomerized, and these are regioselectivity is there. So this on treatment with the sodium persulfate, it will give you the alpha pinene. This is an alpha pinene derivative. Then molecular oxygen reaction with the unsymmetrical ketone. Here, this will be the major product. Means more substituted hydroperoxide will be the major product compared to the less substituted one. I will go to the next slide. In the next slide, unsymmetrical ketone on reaction with the oxygen in presence of triplet sensitizer on irradiation, it will give you the more substituted hydroperoxide are the product. Similarly, if we are taking a steroidal moiety, alpha means 5 alpha hydroperoxides are the major products. This on oxidation with the sodium borohydride will give you alpha hydroxy, 5 alpha hydroxy derivatives of steroid things. So with this, I will go to the next one. Next is about few questions I'm taking. So here, what is meant by quantum yield of the photochemical reaction? That means here, amount of light absorbed by the reactant to form a product is called the quantum yield. If the product is small, quantum yield is small. Then name and write the different isomers of benzene molecule formed under photochemical reaction. That means benzene, when it is subjected to photochemical reaction, means on irradiation, it will give you the divar benzene, fulvalene benzene, and benzene benzene. Then predict the product formed in the following reaction. So here the sensitizers are different. Okay, benzophenone is one side, acetone will be another side. Both are sensitizer, and the reactant is same. Then I will go to the next slide. In the next slide, I am checking Paterno-Bucci reaction. Paterno-Bucci reaction means reaction of carbonyl compound with olefin. So the obtained one compounds are oxytane derivatives. These products are Petrovich reaction. Jablonski diagram, that means fate of excited state molecules. They can come back to the reactant. Then if it is come back to the reactant, we can say that it's only a physical process. Otherwise, it can cross the intersystem crossing, intercrossing, and then fluorescence, phosphorescence. We can also discuss about the what is fluorescence, what is phosphorescence, what is intersystem crossing, what is intra crossing. Those things we have to discuss and we have to draw a Jablonski diagram. Then write the structure factors favoring the Norris type 2 cleavages. So Norris type 2 cleavages means carbonyl compounds having gamma hydrogen. Carbonyl compounds having gamma hydrogen undergo Norris type 2 reactions. Then photosensitization. You know that olefins cannot cross the intersystem crossing. That means cannot produce the triplet. So these olefins can be produced triplet by using the photosensitizers such as benzophenone. Then olefins can directly go to the triplet state. So this process is called photosensitization. Example is benzophenone, right? And this is an example for Petrovich reaction. One will be major, another will be minor. That you have to study. Then photoreduction. Photoreduction means on irradiation, if the carbonyl compounds undergo pinnacle rearrangement, pinnacle product formation, such products are called photoreduction. Photoreduction product. I will go to the next slide. Here, a Dinsart reaction, acrylic. Name of this compound is acrylic with cyclobutadiene. So that means endo product will be the major product. In the endo product, the groups attached to the dienophile will have interaction with the newly formed pi bond. So that's the reason endo will be the major product compared to the exo one. So then suggest the suitable mechanism for the following. So in this one, alpha cleavage. Here also carbonyl alpha cleavage means Norris type 1 reaction. Here alpha cleavage, forming a 1,4 radical and then sigma bond formation. Then it is called cyclobutane formation. Suppose if there is no cyclobutane formation, then sigma bond cleavage, homolytic cleavage, forming two molecule of isobutene. Okay, this is again a Norris type 1 reactions. So aromatic photochemistry of aromatic 1, 3, 5 trimethyl benzene is on irradiation, it will convert it into 1, 2, 1, 3, 4 trimethyl benzene. This is our photochemistry of aromatic compounds. Then I will go to the next slide. In the next slide, I am taking Jablonski diagram. That means you have to draw the diagram. You have to show that what is the excited state, what is the intra crossing, what is intersystem crossing, and you have to show that what is fluorescence, what is phosphorescence. Explanation also you have to give that. Then that will give you the definition of diagram and explanation of fluorescence, phosphorescence, intersystem crossing, intra-crossing will give you the information about the Jablonski diagram. Dipymethane rearrangement. Dipymethane rearrangement means is nothing but a derivative of methane. That means two double bonds are attached to the methane. That one undergo dipymethane rearrangement, forming a vinyl cyclopropane of the product. Norris type 2 cleavage means carbonyl compounds having gamma hydrogen undergo cleavage, forming a product. Such reactions are called Norris type 2 reactions. Then photochemical rearrangement of benzene and its derivative. That means Dewar structure, benzylene structure, and then fulvalene structure. you have to write, and how these products are obtained. That we have to discuss. Then I will go to the next slide. The next slide, photosensitization. It's a repetitive question. Photosensitizers are used uh, because olefins does not cross the intersystem crossing. That means olefins does not form a triplet and direct irradiation. Then photosensitizers are used, and the photosensitizers donate the energy to the olefin. Then olefin will go to the triplet states. This process is called photosensitization. Then complete the reaction. Which of the product is give us target? Right. Then this is again Paterno-Gucci reaction. You have to write the major product and minor product. Then what is the major product of the following? This is again cycloaddition, 2 + 2 cycloaddition. More particularly, you can observe that one more four-membered ring is formed between these two rings. A tricyclic compound is obtained. I will go to the next slide. In the next slide, I am taking few more questions. And here, sketch the basic and modified Jablonski diagram. Highlight their significance. So that means you have to Jablonski question, five marks question or 6 marks question is more common in many of the previous year question paper. So you can prepare well for that. Then complete the following means this is again a photochemistry of carbonyl compound. Means photo reduction. Reduction takes place. Pinnacle formation, where to show that. Bench hydral formation, where to show that. That you can write it with mechanism. Then I will go to the next slide. In the next slide, I will photodimerization of cyclopentanone. That means photodimerization means how cyclopentanone is converted into tricyclic moiety, more particularly butane derivatives. That one you will do. Right. Then write the products and the following reaction, outline the mechanism. This is again what you call pi bond migration. Okay, pi bond migration. This one you can write the mechanism. This is again the Paterno-Gucci reaction. I will go to the next slide. In the next slide, quantum efficiency and quantum yield. So quantum efficiency means amount of photon. It's a ratio of used in the formation of product. If the product is formed stoichiometrically with the sunlight, then it is called quantum efficiency is called. And Paterno-Gucci reaction. Okay, reaction of carbonyl compound with olefin with the formation of oxetane is called Paterno-Gucci reaction. So here, a alkene on irradiation, it will give you the singlet because on direct irradiation, singlet are the product. So then olefin on irradiation with the triplet sensitizer, it will give you the triplet intermediate. Triplet will give you different kind of product. Singlet will give you different kind of product. That means here dimerization is possible. Here non-stereo specific dimerization is possible. Then predict the product and write the mechanism. This is again dipymethane rearrangement. Vinyl cyclopropiles are the product. So you have to distinguish between the discuss the mechanism of Naresh type 1 and Naresh type 2. So Naresh type 1 means carbonyl compounds react with the olefin, forms an oxetane of the product. Naresh type 2 reactions means the carbonyl compounds having gamma hydrogen undergo Naresh type 2 reaction, so forming a product. That's the difference. You can take the mechanism of the Naresh type 1 and Naresh type 2 with an example that will explain. I will go to the next slide. In the next slide, predict the product and name the reaction giving suitable mechanism. That means this is again irradiation of olefin. So dimerization will be the product. Dimerization means singlet stage conversion, and then product formation. Two stereoisomers are possible. Those one we have to write it. Then with the help of Jablonski diagram, that means you have to write the Jablonski diagram, and then you have to explain what is fluorescence, what is phosphorescence, and dendritic system process. Fluorescence means singlet one, phosphorescence means triplet one, and dendritic system creation means conversion of singlet to triplet one. We have to explain in terms of words. Then I will go to the next slide. The next slide, I will take a few more. Type 2 reactions means carbonyl compounds having gamma hydrogen undergo Norris type 2 reaction with an example to explain. Means conversion, isolated carbonyl compounds are the body. How benzene converted into fullerene photochemically? That means you have to write the mechanism, the conversion of benzene to fullerene. Then what is oxidipymethane? That means here oxygen involving dipymethane rearrangement that you have to explain. Explain with the suitable example, give the mechanism of the Claisen rearrangement. So Claisen rearrangement and predict the product and propose a suitable. These two reactions are the very cyclic reactions you can write. Then draw the Jablonski diagram, explain the detail. That means many times Jablonski is repeated, you should be familiar with. And this is again a photo reduction. Photo reduction means how the benzophenone is converted into benzhydrophenol products. This is again acetic acid means it's a what you call nucleophilic substitution reactions. Then with the suitable examples, give the mechanism and the stereochemistry of the product formed in metanobuchi. Oxygens are the products and the reactants are carbonyl compounds and olefin. Then predict the product and propose the mechanism. Pi bond migration one. They are the exam mechanism that right. So this is about the photochemistry. With this, I will stop